Alright, so just going to be a quick video on how to explain or how to read this graph. I think the best place to start is probably with where you see the CDI or Configuration Drag Index. You'll see lines labeled 0 through 150. Essentially, a CDI is it's a constant given to the amount of drag or parasitic drag that is applied to the airframe. We don't have to worry about this. For all intents and purposes, we're just going to reference the 0 line, which is the bottom right-hand line. It's the one that's flat. Just as an example, a F-100 carrying 4 AIM-9Bs on 2 pylons has a configuration drag index of about 28. So you'd have to guesstimate a line between 20 and 40, but we don't need to worry about that. We're just going to look at the CDI line for 0. Temperature, on the other hand, we can ignore this. This is mainly just for thermodynamic bases and how well the engine can perform, or how hard it can perform at those different temperatures and for how long. Ultimately, we don't need to concern ourselves with that. So we're going to now look at the top lines in the upper quadrant of this graph. You're going to see, the first line off to the left is labeled 5, then 10, 15, 20, 25, 30, and then 5 numerical intervals all the way up to 55. Now each line, like for example line 5, that is 5,000 feet. Line 10 is 10,000 feet. 15 is 15,000. 20 is 20,000, so on and so forth. We won't concern ourselves with time just yet. We're going to get there in a second though. So what we're first going to want to do is we're going to want to look at the upper left hand portion of the graph, or the gross weight in thousands of pounds. So 30 is 30,000 pounds, 35 is 35,000 pounds. And when you're testing a vehicle, you want to test its gross weight. So if you're testing a fully loaded plane with fuel and pilot, it's about 30,425 pounds. So if you just roughly locate 30,000 pounds, imagine drawing a horizontal line that goes from left to right and across. So you have that horizontal line there, and then just keep that horizontal line there. Now what we're going to want to do is we're going to want to target a specific altitude. So we're going to reference that horizontal line that we drew that goes from the gross weight of 30,000 pounds, and we'll see where it intersects each individual altitude, or those lines representing that altitude. So 30 intersects 5, 30 intersects 10, but it does not intersect 50. So that means if our plane weighs more than about 28,000 pounds, it cannot reach 50,000 feet in altitude. But let's work through a very simple example. 5,000 feet, or the farthest left of the altitude curves, is the easiest one to work with. So we're going to just stick with the standard gross weight of 30. And we're going to draw a horizontal line coming from left to right. And we see that it intersects line 5, or our 5,000 foot curve. And it's a nice, pretty even, doesn't look like there's going to be any trailing decimals or anything like that. So relatively easy to read off that. So we have that horizontal line that connects there. Now what we're going to do is we're going to draw a vertical line from that point. So you go from 30, you go right, where you connect with the 5,000 foot line, or the line labeled 5, because our plane weighs 30,000 pounds in this example. And then you're going to draw a vertical line from that point where that horizontal line, or the line from 30 to 5, intersects that curve. And you're going to take that vertical line and you're going to draw it all the way down until it meets with our configuration drag index lines. Now we're going to reference line 0. And at 5,000 feet, these are all, kind of clumped together. There's no real discrepancy between 0 or 150. So at 5,000 feet, it's all the same. But we take that vertical line from where 30 intersects with 5. We draw that vertical line down. And then we see it's roughly 2 notches. And we can also see, actually, before we get to there, so yeah, you see that it's 2 notches. So we know it's 2 notches above, and now what we do is we take a horizontal line that goes from where we intersected that CDI 0 curve, or line, and we draw that from right to left, and then we see our time in minutes. Now, I'm not going to exactly eyeball out what that is, but I could tell you between 5 and 0, that thick, fatter line is 2.5 minutes, so that looks like about 30 seconds, or maybe a little bit less than 30 seconds. So now we're going to do 35,000 feet. This one is a little bit more complicated because it's the line isn't perfectly square. So we're going to target our gross weight of 30,000 pounds again. We're going to draw a horizontal line that goes from 30, and we're going to follow it left until it intersects with 35, or that line 35 curve. Now we're going to find exactly where it intersects, and we're going to take a vertical line, and we're going to draw that vertical line all the way down to where it meets with our CDI, or Configuration Drag Index 0 line. And that is the bolded line on the very bottom. And you'll see at 35,000 feet, at 30,000 pounds, when we draw those lines, and we hit our CDI curve, and then we draw our line to our time in minutes, you have about a 3-minute time to 35,000 feet. That's in an essence on how you would read this graph. If you have any questions, feel free to contact me.